Lesson 9.3, B as in boy, trigonometry. We're on example 2, and it's using pH in an application. So let's go ahead and get our formula for pH. There's our formula. Alright, it gives us a bunch of stuff about bogs and fens and marshes and swamps. Suppose that the hydronium ion concentration of a sample of water is 6.3 times 10 to the minus 5. So that's the number that they've given us. How would this wetland be classified? So what is the pH so that we can determine what kind of a wetland it is, because it tells you in the example, value between 6 and 7.5 is a rich fen, and it gives you a whole bunch of different classifications there. So anyway, let's go ahead and find this. pH equals negative, make the parenthesis, log, and what did we say it was? 6.3 times 10 to the minus 5. So we'll make that plus log 10 to the minus 5. Alright, so all we did was took log 6.3 times 10 to the minus 5 and split it up. Because of the multiplication, it's actually a plus. Okay. Then we go ahead and we know this here is just going to be negative 5. And we've got log 6.3. And we have a negative sign out there. So if we distribute that negative, we get negative log 6.3 plus 5, because this and this give me a plus 5. And then I can just take the log of 6.3, take the negative of it, add 5, and I get a pH of 4.2. And if I look at my sources in there in example 2, something with a 4.2 pH is a poor fen. Alright, we're going to go ahead and skip number 3, because I'm not giving you any on loudness of sound, but basically it's the same thing. We're just going to jump right to natural logarithms. Again, this is just kind of a brief overview of logarithms, so if you're not getting all this, that's okay. You'll get it later, or you've already had it. Alright, so let's get into natural logarithms. We talked about E being a natural logarithm. Now, E as an exponent looks like this, just like when we deal with common logarithms, we have 10 to the x power. Okay? Alright, so this is log, and this is log 10, and this is log of E. Okay? But rather than writing log of E, they just write it as ln for natural log, just like we write log of base 10 just as log. So this is log base E, this is log base 10. Everything works the exact same way with ln as with log. It just depends on what you're doing here. So for example, let's say that we're measuring the age of rocks, which I do not believe that this is accurate, because they come up with rocks that are billions of years old, and I don't believe the Earth is that old. But they give us the age of a rock as T as 1.26 times 10 to the 9th ln in brackets 1 plus 8.33. Now there's no way I've got this memorized. A over K over ln of 2. That's the formula. That's not one that they came up with for this particular problem. That's the formula to find out how old rocks are. If you know anything about chemistry, the letter A represents the element argon. The letter K represents the element potassium. So this is argon and potassium, and that's why they give you this information. So letter A says, how old is a rock in which this number is 0 and this number is a number bigger than 0? Okay, we don't have to know what this number is, because if the top number is 0, the whole thing is going to be 0, right? Which means this multiplied by 8.33 is 0. So we can actually write that. I have to write the whole stinking thing again. 1.26 times 10 to the 9th ln 1 plus this is going to be 0 over, whoops, that's not an exponent, that's an ln of 2. Okay, so actually, oh golly, I have this written down wrong, don't I? ln of 1, oh, there, my problem. I've got this in parentheses. That should not be in parentheses. Notice the ln is in the numerator here, so the ln of that over the ln of 2. So that really should be ln of 1 over the ln of 2. And then all you need to do is take the ln of 1, divide it by the ln of 2, and if you do that, you find out it's 0. So we take this times 0, because ln of 1 over ln of 2 is going to give you 0, and the reason you get that is because the ln of 1 is 0. So 0 over whatever ln of 2 is going to be 0. So this cancels out to be 0. 0 times this is 0. So the age of that particular rock is 0. It's a brand spanking new rock. Okay? So if you go and you do part B says that A over K is 0.212. So then you take 0.212 times this, add 1, and you get a number there. I have no idea what that number is off the top of my head, but you take the ln of that over the ln of 2, and you multiply that times 1.26 times 10 to the 9th. Okay, so when you do that, you will get an answer like 1.85 times 10 to the 9th power. So it becomes billions of years old, which is a bunch of baloney. Okay, anyway, let's go to logarithms of other bases. Sometimes you don't get a logarithm of base e or of base 10, but you still need to figure it out. So there is a theorem called the change of base theorem, where if you have a base a, which means anything you want, that's going to equal the log of b of x over log b of a. So let's say, for instance, you want the logarithm base to be something other than a. Let's say you want it to be 10. Well, then you put a 10 there for b. So that's what that b represents. So let's go ahead and do one. Log 517. And the reason you got to change this is because your calculators don't do anything other than the log of 10 or the log of e. So we need to change the base to either e or 10. Alright, so what they did in this one is they changed it using natural logarithms. So what they did is they took ln of x, which is going to be that, over ln of a, which is that, and put it there. Okay? So b is a 10. Or in this, I mean in e, because they wanted to change them both to natural logarithms. So they said, okay, let's do log base e. Remember what I said? Log of e is the same as ln. So that's why that became that. I could have written it as log e of 17 over log e of 5, but I wrote it as ln instead. Alright, and then you figure out ln of 17 divided by ln of 5. This is not equal to. So don't divide this first and then take the ln. You will get the wrong answer. you have to do ln of 17 first, ln of 5, and then divide. Just something to remember there. Alright, so let's take that same formula and do log base 2 of 0.1. Okay, and that is going to be, let's do this with logs. Log, we want to do it with a base 10, so we're going to put log of 0.1 over log of 2. Calculator, log of 0.1, take calculator, log of 2, divide them, and you've switched it over. Just remember though that this is not log of 0.1 over 2. You've got to do them separate. Alright. So that is it for that. We are going to skip example 6 because I really don't want to do this particular modeling diversity of species, and we'll get into some exponential and logarithmic equations in the next video.